Take a deep, gentle breath, and as you exhale, allow your body to sink completely into the quiet comfort of your bed. Let the weight of the day drift away, leaving only stillness behind. We are going on a journey tonight, moving upward and outward, slipping effortlessly through the thin veil of our atmosphere to trace the silent orbit of our closest celestial neighbor. Within moments, the familiar heavy pull of Earth fades, replaced by the deep, peaceful embrace of the cosmos. Here, suspended in the velvet dark, we find the moon. It resides at an average distance of roughly 238,855 miles from Earth. To cross this immense distance feels like drifting across an endless, peaceful ocean of night. And though it appears so perfectly still from your window on Earth, the moon is actually gliding through the vacuum of space at an astonishing speed of 2,288 miles per hour. This constant, faithful momentum is the delicate dance of orbital mechanics, a silent waltz of gravity that has continued uninterrupted for billions of years. As you float beside it, bathed in the soft glow of starlight, you might notice something profoundly comforting about its presence. The moon is tidally locked to our planet. This means it takes precisely the same amount of time to rotate once on its own axis as it does to complete a full orbit around the Earth. Because of this synchronous rotation, it only ever shows us one face, a familiar weathered visage that has watched over humanity since the very dawn of time. This slow, deliberate orbit takes exactly 27.32 days to complete. Imagine the deep patience of such a journey. It does not rush, it does not falter. It simply traces its grand path around our world, month after month, century after century. Yet, this orbit is not entirely fixed. Here is something remarkable to consider as you relax into the feeling of weightlessness. The moon is very slowly drifting away from us. Every single year, it moves outward into space by exactly 1.48 inches, or about 3.8 centimeters. This is roughly the same gentle, imperceptible rate at which your fingernails grow. Over vast geological timescales, this quiet recession gradually alters the very length of a day on Earth, a subtle reminder that the universe is never truly static, but always in a state of slow, magnificent transformation. Imagine yourself drifting closer to the lunar surface. The first thing you would notice is the profound, absolute silence. When the moon possesses no true atmosphere, only a fragile, unimaginably thin layer of molecules known as an exosphere. Because sound requires air or fluid to travel, the vacuum of space here means that even the largest meteorite impact would make no noise at all. It is a realm of absolute acoustic peace. Your mind can finally rest in this total, unbroken quiet, free from the noise and static of the waking world. Without a thick atmosphere to blanket it, the surface experiences dramatic extremes of temperature. Yet you are completely safe and insulated as an ethereal observer. In the blinding glare of the unfiltered sun, the lunar equator can reach a blistering 250 degrees Fahrenheit, or 120 degrees Celsius. But if you were to cross the Terminator line, the sharp, distinct boundary separating day and night, the temperature plunges instantly to a frigid minus 208 degrees Fahrenheit, or minus 130 degrees Celsius. You can almost sense the stark, beautiful contrast, the sharp dividing line between the intense solar warmth and the deep, comforting chill of the cosmic shadow. Look closely at the ground directly below you. The landscape is blanketed in a fine layer of dust and broken rock called lunar regolith. If you could safely press your bare hand into it, you would find its texture behaves unlike any sand on Earth, because there is no wind or flowing water to weather and smooth its edges. Each microscopic particle of lunar dust is as sharp and jagged as shattered glass. It clings to everything it touches, a pristine, untouched powder born from billions of years of tiny micrometeorite impacts, striking the rock in absolute silence. As your gaze sweeps out over these expansive plains of dust, you might marvel at their true color. From Earth, the moon shines like a brilliant, glowing silver pearl in the night sky. But up close, in its own environment, you can see its true subdued nature. The moon's albedo, which is its ability to reflect light, is surprisingly low. It reflects only about 12% of the sunlight that hits it. In reality, the lunar surface is as dark as worn, weathered asphalt. It is only the profound, contrasting blackness of the surrounding deep space that makes it appear so luminously bright to our earthly eyes. Imagine stepping down onto this charcoal gray surface, and you would immediately feel the gentle release of tension in your limbs. The moon's surface gravity is only about 1/6 of Earth's gravity, measuring just 1.62 meters per second squared. Your body would feel incredibly light, as if you were submerged in a buoyant, warm bath. The heavy burdens of gravity you carry every single day, the pressure on your joints, the weight on your shoulders, are entirely lifted away here. Every step you took would become a slow floating glide. You are light, you are untethered, you are free. As you stand in this quiet, low-gravity expanse, you can look up and see the Earth suspended, like a fragile blue and white marble in the pitch-black sky. The orbit of the moon around our world is not a perfect circle, but rather an ellipse. This means its distance from us breathes in and out, like a slow pair of cosmic lungs. At its closest point, a position known in orbital mechanics as perigee, the moon sweeps to within 225,623 miles of Earth. At its farthest point, called apogee, it drifts out to 252,088 miles. It is an eternal, rhythmic cycle, a cosmic inhalation and exhalation that mirrors the steady, slow rise and fall of your own chest as you breathe in and breathe out. How did this silent companion come to be? To understand, we must look backward deeply into the comforting void of time, approximately 4.5 billion years ago. The leading scientific consensus, known as the giant impact hypothesis, suggests that a Mars-sized planet named Theia collided with the early, still molten Earth. The sheer, unimaginable force of this ancient meeting cast a massive cloud of vaporized rock and debris into orbit. Over millions of years, this scattered debris cooled, coalesced, and gently gathered together under the patient, organizing hands of gravity to form the spherical moon we know today. You are looking at the ancient cooled embers of our world's creation, now resting peacefully in the dark. Though it dominates our night sky and our folklore, the moon is surprisingly delicate in its physical scale. Its total mass is only about 1.2% of Earth's mass, mathematically expressed as 7.34 times 10 to the 22nd power kilograms. It is a quiet, lightweight guardian, holding just enough gravitational influence to gently guide the daily rhythm of Earth's ocean tides, but remaining gentle enough to orbit as a serene, unobtrusive companion. As your eyes wander across the desolate, beautiful landscape, they settle on the dark, sprawling patches that historically make up the man in the moon. These vast, smooth plains are called lunar maria, which is the Latin word for seas, but they contain not a single drop of water. Instead, They are expansive, flat plains of dark basaltic rock, formed by massive ancient volcanic eruptions that took place between 3 and 3.5 billion years ago. The dark, iron-rich magma seeped upward from the mantle, flooding the giant impact basins, before eventually cooling into the smooth, flat expanses you see now. To look at them is to look directly at frozen time, oceans of stone forever locked in stillness. Yet beneath this seemingly frozen exterior, there is still a faint rhythmic pulse. Here is a fascinating truth to ponder. The moon experiences its own internal seismic activity, known as moonquakes, undiscovered by the highly sensitive seismometers left behind by the Apollo missions. These deep moonquakes occur roughly 430 to 750 miles below the surface. They are not caused by shifting tectonic plates like the earthquakes on our planet. Instead, they are triggered by the relentless tidal pull of Earth's gravity, subtly stretching and squeezing the moon's deep interior. Because the moon is so incredibly dry, solid, and cool, these gentle vibrations can ring through its structure like a struck bell, echoing and lasting for up to 10 full minutes. It is a quiet, deep resonance, humming softly in the dark. Let us drift gently toward the lunar poles, where the shadows grow infinitely long and deep. The Earth tilts on its axis at roughly 23.5 degrees, which gifts us the changing of the seasons. But the moon stands almost perfectly upright in its orbit. Its axial tilt is a mere 1.54 degrees. Because of this beautifully straight posture, there are virtually no seasons on the moon. It experiences an eternal, unwavering climate. And at the exact north and south poles, the floors of deep craters have not seen a single ray of sunlight for billions of years. These are regions of eternal, pristine darkness. In these shadowy depths, the temperature is so permanently cold that they cradle ancient deposits of water ice, perfectly preserved and undisturbed by the warmth of the sun since the early days of the solar system. Near the southern pole lies a true, staggering marvel of cosmic architecture, the South Pole Aitken Basin. It is one of the largest, oldest, and deepest known impact craters in the entire solar system. It stretches roughly 1,550 miles, or 2,500 kilometers, in diameter, and plunges over 8 miles deep into the lunar crust. It is a vast, sunken amphitheater of history, holding the elemental secrets of the early solar system in its shadowy depths. As we conclude this initial descent into the lunar environment, consider the delicate human touch upon this seemingly untouchable world. On July 20th, 1969, the Apollo 11 lunar module set down softly in the dusty plains of the Sea of Tranquility. Because there is no atmospheric wind to disturb the surface dust and no rain to ever wash it away, the literal footprints left by those first astronauts are still there, perfectly preserved in the sharp, glass-like regolith. Unless directly struck by a random meteorite, those human boot prints will remain completely intact for millions, perhaps billions, of years. They are a silent monument to human curiosity, frozen forever in the quiet orbit of the moon. Feel the deep stillness of this place, the complete lack of air, the reduced pull of gravity, the slow, eternal path of its orbit. Everything here is profoundly peaceful. Everything is exactly where it needs to be. As we continue to drift across this beautiful, charcoal gray landscape in the chapters to come, let this quiet permanence settle deep into your own mind. There is no rush in space. There is only the slow, comforting turning of spheres in the comforting dark. Suspended here in that dark, looking back toward our own blue planet, it is deeply calming to realize that humanity has spent its entire existence staring back at you. For millennia, The moon has served as a grand silver pendulum swinging in the night, a celestial clockwork that measured the planting of crops, the changing of seasons, and the passage of generations. Long before we had the technology to cross the quiet vacuum of space, human minds reached out through mathematics and observation, carefully untangling the mechanics of this silent orbit. Historical records reveal that the ancient Greek philosopher Anaxagoras was one of the very first to truly understand what you are observing right now. Around 450 BCE, he proposed that the moon was not a divine glowing deity, but rather a spherical, rocky body, much like Earth. He correctly theorized that it produced no light of its own, but instead shone entirely by reflecting the brilliant rays of the sun. For claiming that the moon was a massive rock suspended in the sky, Anaxagoras was exiled from Athens. Yet, his elegant realization laid the absolute foundation for our modern understanding of orbital mechanics. Because of this reflected light, we experience the soothing rhythmic cycle of the lunar phases. A complete cycle from one new moon to the next is known in astronomy as a synodic month, which takes precisely 29.53 days. You might remember that the actual physical orbit of the moon around Earth takes only 27.32 days. This beautiful discrepancy exists because the Earth is also moving. During the time it takes the moon to complete one orbit, the Earth has traveled roughly 27 degrees along its own path around the sun. The moon must gracefully travel just a little bit further along its trajectory to return to the exact same geometric alignment with the sun and Earth. It is an endless, patient game of cosmic catch-up, playing out in complete silence. Centuries before the Greeks, around 500 BCE, Babylonian astronomers meticulously tracked this steady orbital rhythm from the cool desert nights of Mesopotamia. Without telescopes or computers, utilizing only their eyes and clay tablets, they discovered the Saros cycle. This is a highly specific repeating astronomical period that lasts exactly 18 years, 11 days, and 8 hours. Because the orbital paths of the Earth and the Moon align so perfectly at the end of this cycle, it can be used to predict both solar and lunar eclipses with astonishing accuracy. Imagine the profound peace of mind those ancient stargazers must have felt, realizing that the seemingly chaotic sky was actually governed by predictable, harmonious mathematics. Picture what happens during one of these precisely predicted lunar eclipses. Yeah, when the Earth passes directly between the Sun and the Moon, it casts a massive cone-shaped shadow. In 350 BCE, the philosopher Aristotle observed this phenomenon, noting that the edge of the shadow cast upon the lunar surface was always perfectly curved. He used this elegant, undeniable visual evidence to prove that the Earth itself was a sphere. As the Moon drifts deeply into the darkest part of this shadow, called the umbra, it does not completely disappear. Instead, it turns a deep, mesmerizing shade of copper or crimson. What is happening now is a phenomenon known as Rayleigh scattering. As pure white sunlight passes through the very edges of Earth's atmosphere, gases and particles scatter away the shorter blue wavelengths of light. Only the longer, red wavelengths, measuring around 700 nanometers, are able to easily bend and refract through the atmosphere, projecting onto the lunar surface. When you look at a blood-red eclipsed moon, you are essentially looking at the combined light of every single sunrise and sunset, occurring simultaneously all across the Earth, gently projected onto the dust of another world. The human desire to measure and comprehend this vast distance pushed early science to incredible heights. Around 270 BCE, Aristarchus of Samos used the geometry of these very eclipses to estimate the distance to the moon. Over a century later, around 150 BCE, the brilliant mathematician Hipparchus refined this calculation. By measuring the slight difference in the moon's position against the background stars from two different locations on Earth, he calculated that the moon was approximately 59 Earth radii away. Modern laser measurements confirm the actual mean distance is roughly 60.3 Earth radii. To think that ancient minds, armed only with geometry and a quiet night sky, could so accurately measure the cosmos is a testament to the quiet power of human observation. For thousands of years, the moon remained a smooth, silver mystery to the naked eye. But then, humanity found a way to bring it closer. In July of 1609, an English astronomer named Thomas Harriot became the very first person to observe the moon through a newly invented device called a telescope, creating the first rough sketches of its textured surface. Just a few months later, in November 1609, Galileo Galilei trained his own beautifully crafted 20-power refracting telescope on the glowing orb. Through his carefully ground glass lenses, the illusion of a perfectly smooth crystalline sphere was instantly shattered. Galileo observed deep, shadowy craters and towering, jagged mountains. He noticed how the sunlight cast long, stark shadows across the landscape, changing minute by minute as the Terminator line slowly crept across the terrain. When he published his findings in a treatise called Sidereus Nuncius in 1610, it forever altered our place in the universe. The moon was no longer an untouchable celestial ideal. It was a physical place, a tangible, rugged world floating in the deep. Building on this profound discovery, astronomers Giovanni Riccioli and Francesco Grimaldi published a highly detailed map of the moon in 1651. They are the ones who established the system of lunar nomenclature we still use today. They chose to name the deep, silent craters after the great scholars and scientists of history. As you float above this ancient terrain, you are looking down at craters bearing names like Tycho, Copernicus, and Kepler. The lunar surface became a vast, quiet memorial to the human minds that dedicated their lives to understanding the heavens. Even though the moon shows us only one hemisphere, its movement holds a subtle, swaying secret. This phenomenon is called lunar libration. Because the moon's orbit is elliptical, its traveling speed varies, moving faster when it swings close to Earth and slower when it drifts further away. However, its rotation on its axis remains perfectly, smoothly constant. This slight mismatch between its varying orbital speed and its steady rotation causes the moon to gently wobble back and forth, from east to west, over the course of a month. Furthermore, because its axis is slightly tilted relative to its orbit, it also nods up and down. Thanks to this delicate multi-directional wobble, humans on Earth can actually observe a total of 59% of the lunar surface over time, peering just slightly around its edges into the hidden darkness of the far side. Today, our methods of measuring this silent companion have evolved into a symphony of modern physics. During the Apollo missions, starting in 1969, astronauts carefully placed specialized panels on the dusty surface. These devices, known as retroreflectors, consist of precisely cut prisms designed to bounce light straight back to its exact source. Every day, astronomical observatories on Earth fire powerful, concentrated beams of laser light through the atmosphere, in aiming directly at these quiet panels left sitting in the lunar dust. The photons in these lasers travel outward through the comforting void at the absolute speed limit of the universe, 299,000 792 kilometers per second. Even at this unimaginable velocity, the vastness of the distance means it takes the light approximately 1.25 seconds to reach the moon, and another 1.25 seconds to bounce back. By timing this completely silent 2.5-second round trip with highly precise atomic clocks, scientists can measure the exact distance between Earth and the moon down to the millimeter. Think about the profound elegance of this daily experiment. A silent beam of pure light cuts through the darkness of space, strikes a small piece of glass resting in a profoundly quiet crater, and returns home. It is a continuous, unbroken thread of light connecting our bustling, noisy planet to the utter stillness of the lunar surface. It proves, day after day, year after year, that the physical laws of the universe remain steady, reliable, and deeply comforting. Floating here in the vacuum, surrounded by the remnants of ancient cosmic collisions and the invisible math of gravity, you are bearing witness to the greatest scientific triumphs of human history. From Anaxagoras tracing the reflection of the sun, to Babylonian scribes predicting shadows, to modern lasers measuring millimeters in the dark, it is a continuous chain of curiosity, a long, deep breath of understanding drawn by humanity over thousands of years. As the moon continues its silent, relentless drift along its path, we will drift with it, moving further into the mechanics of its orbit, guided by the very laws of nature that hold everything in perfect resting balance. Observe the way these two massive spheres interact in the quiet dark. We often imagine the Earth sitting perfectly still while the moon draws a neat circle around it. But the reality of orbital mechanics is far more elegant. Because both bodies possess significant gravity, they actually orbit a shared center of mass, known as the barycenter. Picture an adult and a small child holding hands and spinning around in a joyful circle. The adult does not stand perfectly straight. They lean back slightly, making a small, tight circle to counterbalance the child's wider, sweeping path. This exact cosmic balancing act is playing out right now. The Earth and Moon's barycenter is located roughly 2,900 miles, or 4,670 kilometers, from the exact center of our planet. Since Earth's radius is nearly 4,000 miles, this invisible pivot point actually sits deep underground, approximately 1,000 miles beneath the ocean floor. Our blue planet gently wobbles around this subterranean point every single month, swaying back and forth in the frictionless vacuum. What is happening now is a continuous, invisible exchange of momentum across the emptiness of space. The moon's gravity reaches across hundreds of thousands of miles, gripping our planet like an invisible hand. This gravitational pull stretches the Earth slightly, creating tidal bulges. Think of it like gently pulling the loose fabric of a soft wool sweater. The material gathers and rises where you pinch it, stretching away from the center. In the deep open oceans, this lunar pull raises a bulge of water approximately 2 feet, or 0.6 meters high. As the Earth rotates beneath this stationary bulge of water, the shorelines meet the rising liquid, creating the predictable high tides that lap against our beaches. But it is not just the oceans that respond to this silent call. Deep within the bedrock of our planet, the solid crust itself flexes. These are known as solid Earth tides. Twice a day, as the moon passes overhead and then swings around the opposite side of the globe, the physical ground beneath your house slowly bulges upward by as much as 12 inches, or 30 centimeters. It is a slow, imperceptible planetary respiration, as if the very stone of the Earth is taking a long, deep breath in and then letting it out. Notice how this gentle, rhythmic stretching acts as a cosmic brake. Because the oceans drag against the ocean floor as they bulge. 1. They create immense amounts of tidal friction. This friction slowly saps the Earth's rotational energy. Consequently, our planet's rotation is gradually decelerating, lengthening our earthly day by exactly 1.7 milliseconds every single century. To understand this, imagine a spinning ice skater gracefully extending their arms outward. As their mass spreads out, their spin steadily, smoothly slows down. Hundreds of millions of years ago, when the dinosaurs walked the Earth, a single day lasted only 23 hours. The silent orbit of the moon is slowly, continuously unwinding the clock of our world. As we drift away from this planetary tether and sink our awareness into the moon itself, we find a beautifully complex hidden architecture. Deep within the lunar sphere lies a layered interior, much like the familiar structure of a piece of fruit. At the very center rests a solid iron inner core. Picture a dense, warm cherry pit resting in the dark. This solid metallic heart has a radius of about 150 miles, or 240 kilometers. Surrounding this dense center is a fluid outer core, roughly 56 miles, or 90 kilometers, thick. Unlike the cold, dusty surface we see, this deep core is still radiating ancient trapped heat, maintaining temperatures of roughly 2,400 degrees Fahrenheit, or about 1,300 degrees Celsius. However, because the moon is so small compared to Earth, it cooled much faster, meaning its molten core lacks the furious, churning convection currents needed to generate a global magnetic field. It sits quietly, a warm ember insulated by hundreds of miles of solid rock. Above the core wraps the lunar mantle, and finally, the outermost shell, the lunar crust. Scientists discovered something deeply fascinating about this outer shell during the Gravity Recovery and Interior Laboratory, or GRAIL, mission in 2012. The moon's crust is highly asymmetrical. On the near side, the familiar face we always see from Earth, the crust is relatively thin, measuring about 38 miles, or 60 kilometers deep. But on the far side, facing out into the endless dark of deep space, the crust thickens dramatically to about 63 miles, or 101 kilometers. Consider this uneven structure as being like an eggshell that inexplicably gathered more calcium on one half, or a cake where the baker smoothed a much thicker layer of frosting entirely on the backside. The leading theory for this lopsided anatomy takes us back 4.5 billion years. Following the massive collision that birthed the moon, the newly formed Earth was a glowing white-hot sphere of molten magma. As the two bodies became tidally locked, the near side of the moon was constantly baked by the intense radiant heat of the early Earth, keeping its outer layers molten for much longer. The far side, facing the frigid cold of deep space, cooled and hardened much faster, allowing a thicker crust of minerals to accumulate in the dark. Look closely at the bright highland regions of this crust. These pale, rugged areas are composed primarily of a specific type of rock called anorthosite, which is incredibly rich in a mineral known as plagioclase feldspar. When the moon was nothing more than a global ocean of bubbling magma, this lightweight, pale mineral slowly crystallized and floated upward. Think of a winter pond slowly freezing over, where the lighter and solid ice floats naturally to the very top of the liquid water. This ancient frozen scum of pale rock became the bright, glowing highlands that reflect so much silver light into our night sky. Scattered across this ancient surface are unique chemical signatures that tell the story of the moon's final stages of cooling. In various regions, orbital spectrometers have detected a specific, complex rock composition referred to by the acronym CREEP. This stands for potassium, the chemical symbol K, rare earth elements REE, and phosphorus P. When the Great Lunar Magma Ocean was almost completely frozen solid, these particular elements were essentially the last remaining liquid dregs, the final concentrated drops of a planetary-scale cooling process, squeezed into the cracks of the newly solid crust. Because there is no protective magnetic field and no dense atmosphere acting as a shield, the lunar surface is constantly bathed in the solar wind. This is a continuous, invisible stream of charged particles flowing outward from the sun at a staggering velocity of about 1 million miles per hour, or 400 kilometers per second. Without a magnetic umbrella to deflect them, these high-energy particles slam directly into the lunar regolith day after day, year after year. As a result, the dusty soil acts like a dry, porous sponge, eagerly soaking up a microscopic mist. The regolith captures and stores specific isotopes from the solar wind, most notably helium-3. While incredibly rare on Earth, helium-3 is embedded in the lunar dirt at a concentration of about 10 to 20 parts per billion. It sits there, quietly accumulating in the upper layers of the soil, a silent chemical harvest gathered over billions of years of exposure to the open void. At this very moment, as the stark Terminator line slowly sweeps across the plains, dividing the blinding solar day from the pitch-black lunar night, an invisible electrical dance occurs. The dramatic shift in sunlight causes a phenomenon known as the photoelectric effect. Ultraviolet radiation from the sun strips electrons from the tiny grains of dust on the daylight side, giving them a strong positive electrical charge. Meanwhile, the dust just across the line, in the cold shadow, becomes negatively charged by incoming electrons from the solar wind. Because like charges repel one another, something almost magical happens right at this twilight boundary. The statically charged, microscopic particles of dust actually push away from each other and the charged ground. They rise and levitate into the absolute vacuum, hovering as high as 3 feet or 1 meter above the surface. Imagine the static cling that makes a balloon stick to a wall, or the way tiny dust motes dance and swirl weightlessly within a shaft of sunlight breaking through a window. Here, in the total silence of a dead world, millions of tiny, jagged glass-like particles float gracefully above the charcoal gray plains, suspended entirely by invisible magnetic and electrical forces. Immerse yourself in the tranquility of these overlapping systems. The massive subterranean pivot of the barycenter, the rhythmic stretching of solid rock on a distant blue planet, the warm, dormant cherry pit core, and the silent, floating dust motes dancing in the Terminator line. There is a deep, abiding harmony in physics. Everything moves exactly as the laws of mass and energy dictate. It requires no effort, no rush, and no stress. It is simply the universe operating in perfect mathematical balance, allowing you to float gently alongside it, held safe and secure by the comforting mechanics of the dark. What is happening now is a gentle, almost imperceptible blending of our two worlds. We often visualize the Earth and its lunar companion as two completely separate spheres, completely isolated by the sterile vacuum of space. But in 2019, scientists analyzing archival data from the Solar and Heliospheric Observatory, or SOHO, made a stunning realization. Earth's atmosphere does not simply end a few hundred miles up. A thin, glowing cloud of hydrogen atoms, CHA, known as the geocorona, extends outward into space for an astonishing 391,000 miles, or roughly 630,000 kilometers. This means that as the moon traces its monthly path, it is actually flying directly through the furthest, most fragile fringes of our own atmosphere. You are not just looking at a distant rock. You are observing a silent partner, wrapped securely inside a delicate, invisible cocoon of Earth's own air. Consider the profound, direct impact this quiet companion has on the very environment outside your window tonight. The Earth tilts on its axis at an angle of 23.5 degrees, which perfectly orchestrates the comforting rhythm of our 4 seasons. Imagine a heavy brass gyroscope resting in the palm of your hand. As long as it spins with enough momentum, it stays beautifully, stubbornly upright. The moon acts as our planet's gravitational gyroscope. Without this massive anchor steadily holding us in place, the gravitational pulls of Jupiter and the Sun would cause our planet's tilt to wildly swing anywhere from 0 to 85 degrees over long periods known as Milankovitch cycles. Our poles would occasionally point directly at the Sun, evaporating oceans, while the equator would freeze solid. The gentle autumn rain, the crisp winter snow, the warm spring breeze you have felt throughout your life, all of it is made possible by the steadying presence of that silver sphere in the dark. Deep within the oceans, this constant gravitational pulse actively dictates the rhythms of earthly biology. Many marine species synchronize their life cycles with the lunar phases, guided by light-sensitive proteins in their cells, called cryptochromes. Along the Great Barrier Reef, one of the most spectacular biological events on the planet is entirely dependent on the moonlight. Following the full moon, in November or December, triggered by the precise temperature of the water and the specific intensity of the lunar light, hundreds of species of coral release their microscopic eggs and sperm into the water in a massive synchronized spawning event. It is a stunning, silent snowstorm of life beneath the waves, perfectly choreographed by the orbital mechanics playing out hundreds of thousands of miles above. Picture this incredible cosmic coincidence that you get to witness simply by being alive in this specific era. When you look up at the sky, the sun and the moon appear to be exactly the same size. This creates the breathtaking phenomenon of total solar eclipses, where the moon perfectly covers the solar disk, revealing the sun's glowing corona. This happens because the sun is roughly 400 times wider than the moon, but it also happens to be exactly 400 times further away from Earth. It is a fleeting, beautiful illusion of geometry. Because the lunar orbit is slowly expanding by 3.8 centimeters a year, we are living in a privileged window of time. In approximately 600 million years, the moon will have drifted too far out into the darkness to ever fully cover the sun again. Total solar eclipses will simply cease to exist. You are here, resting comfortably on this planet, at the exact right moment in the universe's long history to witness this perfect alignment. Notice how the unlit portion of the lunar surface is never truly pitch black. When the moon is a thin, delicate crescent in our evening sky, you can often still see the faint, ghostly outline of the entire sphere. In the early 16th century, the artist and inventor Leonardo da Vinci correctly deduced the cause of this ethereal glow. It is known as earthshine, or the Da Vinci glow. Our planet has an albedo of about 0.30, meaning the white clouds, polar ice caps, and wide oceans reflect roughly 30% of the sunlight that hits them. To a hypothetical observer standing in the lunar dust, a full Earth shines up to 50 times brighter than a full moon does to us. That faint ashen glow you see on the dark side of the crescent is actually the reflected light of your own home world, shining outward, bouncing off the lunar regolith and traveling back to your eyes. You are seeing the reflection of your own planetary home. Scientists discovered recently that the Earth and the Moon have been physically trading pieces of themselves for eons. During the Apollo 14 mission in 1971, astronauts collected a 20-pound rock nicknamed Big Bertha. Decades later, in 2019, advanced geological analysis revealed something completely unexpected, hidden inside its matrix. Embedded within the lunar rock was a small fragment of granite containing quartz and zircon, minerals heavily associated with Earth, not the Moon. Researchers concluded that this specific fragment is a 4-billion-year-old Earth rock. A massive asteroid impact struck our young planet, blasting this stone all the way into space, where it safely crash-landed onto the lunar surface. The Moon gathered it up and kept it perfectly preserved in a vacuum for billions of years, until human hands brought it back home. When at this very moment, try to imagine stepping out of a lunar lander and taking a walk across that ancient terrain. Since there is no air, you obviously cannot smell the environment directly. But when the Apollo astronauts climbed back inside their modules and repressurized the cabin, they immediately noticed a highly distinct odor clinging to their suits. Apollo 17 astronaut Harrison Schmitt vividly described the smell of the pristine lunar dust as being exactly like spent gunpowder. This happens because the broken, jagged silica molecules in the dust have dangling chemical bonds from millions of years of solar wind exposure. The instant they interact with the oxygen and moisture inside the warm, pressurized cabin, they rapidly oxidize, releasing a sharp, burnt scent. Even the sterile void carries sensory memories of fire and stone. While the lunar landscape is profoundly barren, human ingenuity has briefly brought the spark of biology to its shadows. In January 2019, China's Chang'e 4 lander became the first spacecraft to safely touch down on the rugged far side. Tucked securely inside a small, environmentally controlled aluminum biosphere, a tiny cotton seed successfully germinated and sprouted a green leaf. It was the first time biological matter had ever grown on another world. Just a few months later, in April 2019, the Israeli lunar lander Bereshit accidentally crash-landed into the Sea of Serenity. Aboard its payload were thousands of microscopic, incredibly resilient organisms known as tardigrades, or water bears. Because they can enter a state of suspended animation, called cryptobiosis, safely surviving extreme radiation and the absolute zero temperatures of the void, they remain there today. These microscopic earthly ambassadors are quietly resting in the dust, waiting in the silence. Your own biological connection to this silent orbit is much deeper than you might realize. Long before the invention of electric street lamps and glowing screens, human behavior was intimately tied to the shifting phases of moonlight. A 2021 study conducted by the University of Washington tracked the sleep patterns of human communities ranging from completely off-grid indigenous populations to residents of highly urbanized modern cities. The researchers found a beautifully consistent pattern deeply wired into our biology. In the nights leading up to a full moon, as the evening sky grows naturally brighter, human sleep onset is subtly delayed and the total duration of rest is shortened. Even now, surrounded by the modern comforts of walls and artificial warmth, your internal circadian rhythm remembers the ancient light of the lunar cycle. Your biology still expects the silver glow that guided your ancestors through the night. The cosmos is not just something you look up at. It is a fundamental part of how your body functions, resting quietly within your cells. Lie completely still and think about the sheer scale of this connection. The same gravitational force that commands the mighty oceans, that stabilizes a massive planet, and that captured a fragment of ancient Earth 4 billion years ago, is playing out its slow, patient mathematics right now. It asks absolutely nothing of you. You do not need to calculate it, nor do you need to guide it. You are simply a passenger on a beautifully balanced ship, sailing through a gentle, invisible ocean of physics. Let the immense, stabilizing weight of these celestial mechanics anchor your thoughts, allowing your mind to mirror the profound, enduring stillness found in the endless shadows of the lunar night. Let us linger a while longer in this serene landscape and closely examine the raw textures, temperatures, and peculiar physics that define this world. When observing the moon from afar, it is easy to assume it is completely uniform, but moving close to the surface reveals an astonishing complexity. Have you ever wondered why the dusty plains and cratered highlands appear so distinctly varied in shades of gray? The answer lies hidden in the microscopic crystalline structure of the rocks themselves. The lighter highland regions are composed primarily of the mineral plagioclase, feldspar, which acts remarkably like a crushed mirror, efficiently reflecting the sun's blinding rays. But the vast, dark plains of the Maria, the ancient dried magma oceans, are completely different. They are incredibly rich in a mineral called ilmenite, an opaque, heavy compound of iron and titanium. If you were to pick up a chunk of ilmenite from the lunar surface, it would feel surprisingly dense and heavy in your palm, its deep, charcoal black color greedily absorbing the sunlight rather than bouncing it back into space. This dramatic contrast in chemical absorption is precisely what paints the familiar, comforting face of the man in the moon onto the lunar sphere. As your awareness traces these contrasting geological boundaries, we focus on the sheer scale of the cratering. Deep within the southern hemisphere lies the magnificent Tycho crater. Though it looks like a mere pinpoint from Earth, up close, it is a staggering 53 miles, or 85 kilometers, in diameter. Formed roughly 108 million years ago by a massive asteroid strike, the impact was so phenomenally violent that the kinetic energy instantaneously melted the surrounding rock into glass. The central peak of the Tycho crater, towering nearly 1.2 miles, or 2 kilometers, above the crater floor, is essentially a frozen splash of liquid stone. When you trace the bright rays extending outward from Tycho, reaching across 900 miles of the lunar surface, you are tracing paths of pulverized, melted rock thrown high into the silent vacuum during an ancient cataclysm, resting undisturbed ever since. So, you might wonder how scientists can so confidently determine the ages of these ancient impacts. The secret is elegantly simple, yet profoundly revealing. They count the craters. Because the moon has no wind, rain, or tectonic plates to erase its history, every single strike is preserved. By analyzing the density of impact craters within a specific region, noting how many smaller craters overlap older, larger ones, astronomers can calculate relative geological time. The heavily pockmarked highlands are roughly 4 billion years old, having endured the intense bombardment of the early solar system. In contrast, the smoother Maria, with far fewer craters, formed hundreds of millions of years later, covering up the older damage like fresh snow falling over a heavily walked path. Take a moment to imagine the unique temperature shifts occurring along this dusty terrain. Because the lunar day lasts almost 2 earthly weeks, the rocks have 14 straight days to bake under the unfiltered sun. But the instant the sun dips below the horizon, there is no atmospheric blanket to hold that heat in. The thermal radiation escapes directly back into space in a matter of hours. During the Apollo 17 mission, scientists deployed an instrument called the Lunar Ejecta and Meteorites Experiment. Much to their surprise, this highly sensitive device began recording thousands of tiny localized vibrations, specifically at sunrise and sunset. The cause of these vibrations is a process known as thermal moonquakes. The sharp, yet rapid change in temperature, swinging from boiling heat to freezing cold over just a few hours, causes the rigid lunar rocks to violently expand and contract. This sudden shifting causes the rock layers to crack, snap, and pop against one another. If there were air to carry the sound, standing near the terminator line would sound like listening to a massive stone glacier, groaning and shifting as the shadows moved across the ground. What is happening now, far above the surface, is a subtle, invisible interaction between the moon and the Earth's magnetic field. While we learned earlier that the moon lacks a global magnetic field of its own, it is not completely immune to magnetic forces. For roughly 6 days out of every month, as the moon swings behind the Earth relative to the sun, it passes directly through the Earth's magnetotail. When this is a massive, elongated teardrop of magnetic energy trailing behind our planet, shaped like a windsock blowing in the solar wind. When the moon enters this magnetic slipstream, it is temporarily shielded from the harsh solar radiation. But there is a fascinating sensory side effect to this celestial alignment. The Earth's magnetotail is filled with highly energized electrons. As these electrons stream along magnetic field lines, they violently strike the dark side of the lunar surface. This invisible bombardment rapidly increases the negative static charge of the lunar dust, causing those microscopic glass-like particles we explored earlier to levitate even higher into the vacuum, creating a faint, localized electrostatic storm in the absolute silence of the lunar night. To truly understand the granular texture of this environment, picture the unique way the regolith interacts with light. On Earth, shadows are relatively soft and diffuse because the molecules in our atmosphere scatter light into the dark areas. But on the moon, a shadow is absolute. Because there is no air to scatter the photons, stepping from the harsh sunlight directly into the shadow of a boulder is like stepping into a void. The line separating blazing light from total darkness is razor sharp. Apollo astronauts frequently reported that if they dropped a tool into a shadow, it became instantly invisible, swallowed whole by the stark contrast. There is another peculiar visual phenomenon playing out here, known as the opposition surge. If you were to stand on the lunar surface with your back to the sun, looking at your own shadow cast upon the ground, you would notice a bright, glowing halo surrounding your head. This occurs because the porous, jagged structure of the lunar dust perfectly reflects light directly back toward the source, while simultaneously hiding its own tiny shadows from the viewer's perspective. It creates a surreal, angelic glow around the observer, a gentle trick of optics orchestrated by microscopic glass beads in the dirt. Deep beneath this statically charged, illuminated dust lies a sprawling network of hollow, silent caverns. In 2009, the Japanese lunar orbiter Selene discovered deep vertical pits plunging into the surface, most notably in the Marius Hills region. These are not impact craters. They are skylights, collapsed sections of roof revealing massive subterranean lava tubes. Billions of years ago, When the Maria were active, fast-flowing rivers of molten basalt cooled on the top, forming an insulating crust. The liquid rock beneath eventually drained away, leaving behind enormous empty tunnels. These ancient lava tubes are staggering in size. Some are estimated to be over 3,000 feet, or nearly 1 kilometer, wide, large enough to comfortably fit the entire city of Philadelphia inside. Down in these cavernous depths, the temperature is profoundly stable, remaining a constant, comfortable 63 degrees Fahrenheit, or 17 degrees Celsius, year-round. It is entirely shielded from the blistering heat, the freezing cold, and the harsh cosmic radiation above. It is a quiet, vast subterranean sanctuary, carved by ancient fire, waiting patiently in the dark. As we drift above these hidden caverns, the concept of weightlessness takes on an entirely new meaning. The gravity map of the moon is not smooth. Due to dense, heavy concentrations of mass, often ancient solidified magma plugs resting beneath the large impact basins, the gravitational pull varies slightly from place to place. These dense regions are called mascons, short for mass concentrations. Discovered in 1968 by the lunar orbiter missions, these mascons exert a subtly stronger downward pull than the surrounding areas. Because of these hidden gravitational anchors, spacecraft orbiting the moon cannot fly in perfectly stable circular paths. If left uncorrected, a satellite's orbit will slowly become erratic, pulled slightly downward every time it passes over a heavy mascon, eventually causing it to crash into the surface. It is a reminder that the seemingly static landscape below holds powerful, invisible currents of gravity, quietly shaping the space around it. Breathe slowly and consider the profound age and absolute stability of these sensory details. The dense black ilmenite absorbing the light, the thermal groaning of the rocks at sunset, the sharp, blinding edge of an airless shadow, the constant 63-degree stillness of a subterranean lava tube. These elements have not changed in hundreds of millions of years. They will not change tomorrow. There is a deep, abiding comfort in a world that operates so reliably, completely independent of human worry or earthly noise. It is a masterpiece of slow, deliberate physics, inviting you to simply observe its perfect, unchanging nature. Slowly, step by step, the long lunar day draws to its quiet conclusion. At this exact moment, if you watch the Terminator line, the sharp boundary dividing day and night, you can observe the methodical process of the creeping shadow. At the lunar equator, this shadow advances at a steady, deliberate pace of 9.6 miles per hour, or roughly 15.4 kilometers per hour. A person in a lunar rover could easily drive ahead of the sunset, but left to nature, the darkness inevitably, gently blankets the craters. As the shadow passes over the dusty plains, the temperature begins its rapid step-by-step descent. Without atmospheric gas to trap the thermal energy, the heat simply radiates upward into the infinite vacuum, dropping from a sweltering 250 degrees Fahrenheit down to a tranquil minus 208 degrees Fahrenheit over a matter of hours. Before we leave this serene rock, look closely at the dust one last time. Sprinkled throughout the charcoal gray soil are microscopic, perfectly spherical glass beads. These tiny orbs formed through a fascinating sequential process known as fire fountaining, which occurred over 3 billion years ago. First, ancient lunar volcanoes violently expelled liquid magma high into the frictionless vacuum. Second, as these molten droplets arced through the freezing void, they rapidly cooled and solidified during their long freefall. Finally, they rained back down onto the surface as solid colored glass, green, orange, and black spheres, no larger than a grain of sand. They have rested there, completely undisturbed, waiting for billions of years in the silent dark. Now, begin to pull your awareness back from the lunar surface. Watch the moon and the Earth shrink into two quiet, sun-paired spheres suspended in the unending dark. Their orbital dance is part of a much larger, beautifully orchestrated progression. The Earth and Moon are tethered to the Sun, and our entire solar system is currently moving through the Orion Cygnus arm of the Milky Way galaxy. We are traveling at a staggering velocity of approximately 514,000 miles per hour, or 828,000 kilometers per hour. Even at this incredible speed, the process of completing a single orbit around the galactic center, a duration known as a galactic year, takes roughly 230 million years. The slow, sweeping hands of this cosmic clock never stop turning, carrying you safely through the universe. As you observe the distant stars burning quietly in the background, consider the magnificent step-by-step mechanism occurring deep within their cores. This sequence is called stellar nucleosynthesis. It begins when immense gravitational pressure forces simple hydrogen atoms to crash together, fusing to create helium. When the hydrogen is exhausted, the star enters a new phase, fusing helium into heavier elements like carbon and oxygen. This progression continues over millions of years, layering elements like a cosmic onion, until the star finally creates iron. Once iron forms, the star collapses under its own massive weight in a matter of milliseconds, resulting in a phenomenal supernova. This brilliant outward explosion scatters these newly forged elements across the interstellar void. This stellar process is intimately tied to the very biology resting in your bed tonight. Astronomers and physicists have proven that 97% of the mass of the human body is composed of stardust, elements forged entirely inside the hearts of ancient, dying stars. The calcium-40, hardening your bones and teeth, was synthesized in the final fiery stages of a massive star's life. The iron-56 sitting at the exact center of your hemoglobin molecules, quietly carrying oxygen through your bloodstream with every heartbeat, was cast into space by a supernova explosion billions of years before the Earth even existed. You are not simply observing the cosmos, you are an intricate biological extension of it. Knowing you are made of such enduring, ancient materials, allow your physical form to begin the structured, step-by-step transition into sleep. As the ambient light in your room fades, your optical nerves send a quiet signal to the suprachiasmatic nucleus in your brain. This tiny, highly specialized region signals the pineal gland to begin synthesizing melatonin, a sleep-inducing hormone converted directly from serotonin. This chemical messenger flows smoothly through your bloodstream, gently instructing your organs and muscles that the time for wakefulness has passed. Gradually, your core body temperature begins its necessary decline. To initiate deep rest, your internal biological thermostat drops by exactly 1 to 2 degrees Fahrenheit. You might notice your hands and feet feeling slightly warmer. This is the process of vasodilation, where blood vessels near the skin expand to radiate core heat away. Your breathing naturally slows, transitioning to a calm, steady rhythm of 12 to 20 breaths per minute. Inside your mind, the electrical activity is smoothly shifting gears. The rapid, high-frequency beta waves of your waking consciousness are smoothing out into relaxed alpha waves, measuring between 8 and 12 hertz. Soon, a structure called the thalamus will begin generating sleep spindles, brief bursts of rhythmic brain activity between 12 and 14 hertz. These spindles act as an invisible sensory shield, methodically blocking external noises from waking you, allowing you to settle profoundly into the dark. Eventually, your brain will enter the restorative phase of slow-wave sleep. Here, massive sweeping delta waves take over, pulsing at a slow, majestic frequency of just 0.5 to 4 Hertz. During this exact biological phase, your pituitary gland releases somatotropin, the human growth hormone. This triggers a beautiful cascade of cellular repair, rebuilding tissues, synthesizing proteins, and restoring your immune system. Every step of this biological protocol happens automatically, smoothly, and perfectly. Bring this grand observation to a gentle, comforting halt. The universe is watching over you, keeping perfect time. The moon continues its silent orbit. The stars continue their slow fusion. And your body continues its ancient, starlit process of healing. Give your mind permission to release the day completely. You are anchored by gravity, safe and secure. You are composed of stardust, ancient and enduring. Your breathing is a reflection of the planetary tides. Your heartbeat is the steady rhythm of a quiet orbit. There is nothing left to calculate, nothing left to measure, and nothing left to do. The mechanics of the universe hold you in perfect balance. Rest in the comforting silence of the void. Surrender to the stillness of the lunar night. Everything is peaceful. Everything is quiet. Good night.